In this video, I'll connect Proxmox virtual machines to a physical switch so that I can play around with switch features such as VLAN, port security, access control list, port-based authentication, etc. But I'll be focusing on VLAN and port security for now. The switch that I will be using here is a Linksys 8-port layer 2 switch. Here in Proxmox dashboard, these are the VMs that I've created so far. Now we'll be using mainly this pfsense firewall, this two Windows 11s, and Server 2022 to demonstrate VLAN and port security. When you need to take a look at how I built these VMs, please refer to the links posted in the description. Here is a diagram of how the setup looks like. It appeared there is so much going on here, but when looking at this in a simplistic view, it will look like this. pfsense firewall has a WAN connection to the internet and LAN connection going to port 1 at this layer 2 Linksys switch. From port 2 of this switch, we have a connection going to Windows 11-1 machine representing VLAN 10. From port 3 of the same switch, we have a connection going to Windows 11-2 machine representing VLAN 20. Looks simple, right? Going back to the more detailed diagram, I have this Beelink MiniPC here running Proxmox with IP 192.168.8.250. This Beelink MiniPC comes only with one Ethernet port, auto-named as ENP1S0. This physical port ENP1S0 is cabled or Ethernet wired to a router with gateway 192.168.8.1. This router is running DHCP on the LAN with network address of 192.168.8.0/24. I have a physical PC sitting on the same 192.168.8.x network for managing this Proxmox box. ENP1S0 is by default virtually connected or linked to this auto-created virtual switch VMBR0. I've explained this in my previous video, kindly check it out. In this pfsense firewall VM, Net0 network adapter is linked to VMBR0. This will act as the internet-facing interface or WAN interface. Once this pfsense is up and running, Net0 will obtain a DHCP assigned IP address within this LAN network address of 192.168.x something coming from this router. Take note, this is a simulated WAN as this is still part of the private IP address behind the LAN of this router. I'll be managing this pfsense firewall from the same management PC via the assigned IP address of this Net0 or WAN interface. This second network adapter Net1 is linked to VMBR1 virtual switch, and this will serve as our LAN interface with network address 192.168.1.0/24. We have a physical port with a strange looking name and is linked to VMBR1. This physical port ENX00 something is cabled to port 1 at the switch. Now you may ask, where does this physical port or these three physical ports comes from? As we know, this MiniPC comes only with one physical port ENP1S0. These three physical ports with a name that starts with ENX00 comes from this USB to Ethernet adapter. I bought 3 of these and connected to the USB ports of this MiniPC. 2 of these adapters are inserted at the back and the third one is at the front. Let us go to Proxmox dashboard and check the adapters. Click Beelink. Under System, click Network. ENP1S0, as we know, is the default physical port, which is a network device type. These 3 additional adapters are auto-detected and auto-named by Proxmox. These are network device type, same as ENP1S0. They are not active yet except for ENP1S0. Moving to the virtual switches VMBRs. VMBR0 is the default virtual switch, and it is a Linux bridge type and is associated to ENP1 as 0. If we double click VMBR0 to edit or take a look at the settings, it has a statically assigned IP address of 192.168.8.250, which is the Proxmox web management, and gateway of 192.168.8.1, pointing to the router LAN gateway IP. In bridge ports, we have ENP1 as 0 added in here. VMBR1 and VMBR2 are manually created, which I use for LAN and DMZ from my previous video. These two have no association to any physical port. From the diagram, I need to associate this physical port ending in 2B9 to VMBR1 for the LAN connection. I'll edit this 2B9 just to copy the complete name. Edit VMBR1 and paste the name in bridge ports. I'll add a comment here that this is for LAN. Click OK. To apply the change, click Apply Configuration and click Yes to confirm. We now have VMBR1 associated or linked to the physical port ending in 2B9 for LAN. As you noticed, this port is now active. It appears that once a physical port is associated to a virtual switch, it will become active. While we are here, let's associate the rest of the remaining physical ports to a virtual switch. In the diagram, this second physical port name ending in 822 will be linked to VMBR2 for VLAN 10. As you can see, I could not copy or highlight it from here, and that is why I had to edit it just to copy the whole name. After copying the complete name for the 822 physical port, we can edit VMBR2 and paste the port name in bridge ports. I'll add a comment and type VLAN 10 so that I know what is this used for. Click OK. Apply the change by clicking Apply Configuration. Port name ending in 822 is now active. For the third adapter, it has to be linked to VMBR3 for VLAN 20. We don't have VMBR3 yet. We'll be creating one then. But before that, let us edit this port name ending in 86E to copy its full name. Click Create and select Linux Bridge. Name is already set to VMBR3. Paste the name in bridge ports. Add a comment that this is for VLAN 20. Click Create. For the change to take effect, click Apply Configuration. To summarize, VMBR1 is associated to physical port ending in 2B9 for LAN. VMBR2 is associated to the physical port ending in 822 for VLAN 10. And lastly, VMBR3 is associated to the physical port ending in 86E for VLAN 20. Back in the diagram, this 2B9 port is physically cabled to port 1 at the switch. This 822 port is physically cabled going to port 2. I have a Windows 11-1 VM, net0 linked to VMBR2, and this VM will represent VLAN 10 with network address of 192.168.10.0/24. For this 86E port, it is cabled going to port 3. We have a Windows 11-2 VM, net0 linked to VMBR3, representing VLAN 20 with network address of 192.168.20.0/24. What are these trunk/tagged and access/untagged ports? These are VLAN terms. Basically, access or untagged port is a port that is assigned to a single VLAN, whereas a trunk or tagged port is a port in which wherein multiple VLANs are assigned. In other words, access or untagged port can carry traffic for one VLAN only, while a trunk or tagged port can carry traffic for several VLANs. So port 2 will only pass VLAN 10 traffic, and port 3 will only pass VLAN 20 traffic. Port 1, a trunk or tag port, will pass both traffic for VLAN 10 and VLAN 20. This Linksys Layer 2 switch has a statically assigned management IP of 192.168.8.230 and is accessible via this port 6 link going to the router from the same management PC. Let us log into the switch web management. In VLAN management, there is only one VLAN, and by default the VLAN ID is 1. This is what we call native untagged VLAN 1. In memberships, all 8 switch ports from GE1 to GE8 are untagged on VLAN ID 1. Under interfaces, we can see all ports default interface VLAN mode status is trunk with a port VLAN ID or PVID of 1. Let us add VLAN 10. This is a single VLAN. Enter 10 for VLAN ID. Usable VLAN ID starts at 2 up to 4094. I'll name this as VLAN 10 and click apply. In the VLAN table, we have a new entry VLAN ID 10, which is a static type since we manually created this one. I'll go ahead and do the same for VLAN 20. VLAN 10 and VLAN 20 are added, but no ports are a member of this yet. From the diagram, we need port 2 to be an access port and untagged for VLAN 10, and port 3 to be an access port as well and untagged for VLAN 20. But for port 1, we need this port to be a trunk port untagged for both VLANs 10 and 20. In VLAN memberships, select VLAN ID 10 and click search. As expected, none of the ports are a member of VLAN ID 10. Under GE1 or port 1 equivalent from the diagram, which is the trunk port, I'll select tag. Under GE2 or port 2 equivalent from the diagram, which is an access port for VLAN 10, I'll select untag and click apply. In interfaces, GE1 is already a trunk port, and under VLAN memberships, we have 10T, which means VLAN ID 10, and T is for tag. For GE2, it has a PVID of 10 now, but we need to change the VLAN mode from trunk to access. Select GE2 and click Edit. Select Access for interface VLAN mode and click Apply. Now GE2 port is in access VLAN mode. We'll do the same process for VLAN 20. In VLAN memberships, select 20 for VLAN ID and click Search. Under GE1, which is our trunk port, select tag. Under GE3 or port 3 equivalent from the diagram, which is an access port for VLAN 20, select untag and click apply. GE1 trunk port now has two VLAN members tagged for VLAN IDs 10 and 20. GE3 is now set to PVID 20 and we just need to change the VLAN mode to access. Edit GE3 and select access. Looks like we are done with the VLAN configuration on the switch. Back to Proxmox dashboard. Let us go to pfsense VM hardware section. I have two network adapters in here already. Net0 is linked to VMBR0 for the WAN. Net1 is linked to VMBR1 for the LAN. From the diagram, Net0 is connected to VMBR0 for the WAN. And Net1 is connected to VMBR1 for the LAN. Let us start this VM then. pfsense firewall is up and running. The DHCP assigned IP on the WAN interface is 192.168.8.113, while LAN IP has a static IP of 192.168.1.1. We'll open a new tab in the browser and enter https://192.168.8.113 to get to the pfsense web management GUI. In case you wonder how was I able to access the web management via the WAN IP address, let me go to the firewall rules. Under WAN, I added this rule in advance. Edit this rule to see the configuration details. Action is pass. Interface is WAN. Protocol is TCP. Source is any. Destination is the WAN address or the IP address assigned to the WAN interface. Destination port is HTTPS 443. This rule is allowing HTTPS access from any source going to the WAN address of the WAN interface. How do we add VLANs in pfsense? Let's go to Interfaces and click Assignments. We have only two interfaces here, WAN and LAN. Under VLANs tab, click Add. For parent interface, select VTNet1, that is the LAN interface. For VLAN tag, enter the VLAN ID 10. Leave VLAN priority as it is. I just put in VLAN 10 for the description, then click Save. We'll add VLAN 20 as well in here. Now both VLAN 10 and VLAN 20 are created. Going back to interface assignments. We have this available network ports now that we can add. Let us add VLAN 10 first. Select VLAN 10 and click Add. By default, it is auto-named as OPT1. Click OPT1 to configure this VLAN 10 interface. Check the box to enable the interface. I'll change the description here to VLAN 10. Select static IPv4 for the IPv4 configuration type. Under static IPv4 configuration, enter 192.168.10.1 and subnet mask is /24. This will be the gateway IP of the machine on VLAN 10. Then click Save. We have a message here saying the changes must be applied to take effect. Also notice it says to adjust the DHCP server if needed. I need DHCP to be enabled on this VLAN 10, and this is the next step that we'll configure. Let us go to Services and select DHCP server. DHCP server for LAN is already enabled by default. Click VLAN 10 tab. Check the box to enable DHCP server on VLAN 10 interface. For the address pool range, I'll start at 192.168.10.100 and ends at 192.168.10.200. I'll leave everything as default, having a DNS server and gateway of 192.168.10.1. Save the configuration, then click Apply Changes. Let us test if Windows 11-1 VM can obtain an IP address on VLAN 10 network address range. In Windows 11-1 VM hardware section, ensure net 0 of this VM is set to VMBR2, which is the virtual switch we designate for VLAN 10. Good to start this VM then. Let us open command prompt and verify the IP address with the command ipconfig/all command. This machine indeed obtains an IP address by DHCP of 192.168.10.100, which is the starting IP we assigned in the DHCP pool for VLAN 10. Both default gateway and DNS server IP is pointing to 192.168.10.1, which is the VLAN 10 static IP address. We have verified that DHCP is working on VLAN 10. How about connectivity? Let's see if we can ping google.com. It could not find host google.com. In Edge browser, it says google.com server IP address could not be found. What do you think is the issue here? If you guess there is no firewall rule to allow the traffic from this VLAN 10 network, that's absolutely correct. Let's go to firewall rules and select VLAN 10. There are no rules in here yet. Let's add a rule to allow VLAN 10 network traffic to reach the internet. Action is set to pass. Interface is VLAN 10. Set the protocol to any. For the source, select VLAN 10 subnets, that is the VLAN 10 network address 192.168.10.0/24. Set the destination to any and then click Save. Back in Windows 11-1 VM's command prompt, pinging google.com now works. In Edge browser, we can reach google.com page as well. Back to interfaces assignments. Let us complete setting up VLAN 20. Add this VLAN 20 interface. Click OPT2 to configure it. Enable the interface. I'll put VLAN 20 for the description. Select static IPv4 for the IPv4 configuration type. Set a static IPv4 address of 192.168.20.1 and subnet mask is /24. Click Save and apply the changes. I click Apply Changes twice in here and this gives out an error. You can just ignore this. Next, enable DHCP for VLAN 20. Add the address pool range starting at 192.168.20.100 till 192.168.20.200. Leave everything by default, save and click Apply the changes. Add a firewall rule under VLAN 20 to allow traffic from VLAN 20 network going to the internet. Action is set to pass. Interface is VLAN 20. Set protocol to any. Source is from VLAN 20 subnets, or that is 192.168.20.0/24. Destination is set to any. Save and apply changes. Let us test if Windows 11-2 VM can obtain an IP address on VLAN 20 network address range. In Windows 11-2 VM hardware section, ensure net0 is linked to VMBR3 for VLAN 20. Let's start this VM then. From the command prompt, ipconfig/all output shows this machine has a DHCP assigned IP of 192.168.20.100. Pinging google.com is fine, and in Edge browser, able to reach Google as well. In the diagram here, I'm just tracing how the traffic flow from VLAN 10 and VLAN 20 going to the internet. Can I ping from Windows 11-1 on VLAN 10 going to Windows 11-2 on VLAN 20 or vice versa? Looks like it's reachable on both sides. This should not be allowed, right? Because the whole purpose of VLAN is to separate the network unless we need inter-VLAN communication. To fix this, we just need to add a firewall rule that will block the traffic from one VLAN going to the other VLAN. Let us go to firewall rules. Under VLAN 10, add a new rule. Action is block. Interface VLAN 10. Protocol is set to any. Source is VLAN 10 subnets. Destination is VLAN 20 subnets. Add a description in here. Block traffic from VLAN 10 to VLAN 20, then save. This time pinging 192.168.20.100 from this Windows 11-1 machine is not reachable. Let us apply the same process for VLAN 20. So let's add a block rule to block the traffic from VLAN 20 going to VLAN 10. After adding the block firewall rule, pinging 192.168.10.100 on this Windows 11-2 machine is not reachable anymore. The last part of this video is configuring port security at the switch and see how it works. Port security is a switch security feature that limits access on a port to a machine with specific MAC addresses. Back in the switch web management, let us go to security and under network access control, select port security. By default, all ports are unlocked, meaning not configured yet, and the learning mode is classic lock, which means all learned MAC addresses on the port are locked and the port does not learn any new MAC addresses. Let us test this on GE2 or port 2, which is on VLAN 10. Edit GE2, check the lock box for interface status. This means we are enabling port security. Then learning mode is default to classic lock that only allows one MAC address. For action on violation, let us select shutdown. We can enable trap for SNMP, but I don't need this for now. Click apply. The goal here is to lock port GE2 for Windows 11-1 machine MAC address and shut down the port when it sees a different MAC address. How does the switch knows that it will only accept the learned single MAC address on this GE2 port? The switch will auto add the learned MAC address to a static MAC address in the MAC table, as you can see in here. This MAC address ending in 4996 is the Windows 11-1 machine MAC address. Let us go to Windows 11-1 machine and in the command prompt enter ipconfig/all. Here is the physical address ending in 49-96, which is the same MAC address that has a static entry at the switch. Let's see port security in action. I'll swap server 2022 for this Windows 11-1 VM. I'll shut down Windows 11-1 first. Ensure server 2022 net 0 is linked to VMBR2 for VLAN 10 and start this VM. Server 2022 VM is up, which is connected to GE2. Let us check the port status. As you can see, GE2 is down, saying port lock. Port security is triggered and brought the port to go down because it sees another MAC address. I'll shut down this server 2022 VM and start Windows 11-1 VM. The question is, will the GE2 port go up automatically? Let us verify then. It does not go up automatically by itself. We'll have to edit the port and reactivate it. Now port 2 or GE2 is up. Windows 11-1 VM has connectivity again. That is all I wanted to share. If this video helps you in any way, I appreciate the likes and kindly consider subscribing. Take care and see you on the next video.